There's no official release, right?
No, I mean, all of
Okay.
our work's getting AI tested tomorrow, so.
Okay, let's
we've never had
move on
an issue.
to the next big chapter. We want to talk about the lipids. So today, we want to talk about the introduction. Then we talk about the lipids oxidation next week, or now next week, following the spring break. So first question is really tricky. What is the definition of lipids? That's a little bit tricky because no very good answer. So one in our textbook is compounds can be dissolved in organic solvent, such as alcohol, such as chloroform. But then there is an exception. What are the exceptions? Short chain fatty acids and glycerides, which is a monoglycerides. So that's the definition, okay? You can think about your own definition. That's a definition in the textbook. Now, we talk about the lipids. We want to talk about the function very briefly. This is, everybody knows, it will be like a support, and it will be like stabilization, modification, and try to help a food product have the good nutrients, had energy obviously, and also flavor, texture, all kinds of things, including color sometimes, okay? So we're gonna skip that part. So that's a function. Then we want to talk about the lipids. Very obvious in the food products. We could be separate into two different sections. If it's solid status, that's fat. Liquid status, it is oil. That's a basic, very simple status. Now there's a little bit different from the water. In our textbook, when they talk about water, there is an intermediate status which is glassy status. The lipids, they do not have a glassy status. So we didn't mention for the water, but I just want to let you know, water have another status, but lipids on the foods, basically solid, fat, liquid is oil. We also want to talk about, they could be separated into non-polar, unpolar, or the polar status. This is, we know, like cholesterol, triglycerol, those are unpolar. And the polar, we know, obviously, is phospholipids. So we talk about this all the time as major components in the cell membrane system at the fluid mosaic model. We say it has a hydrophilic head and hydrophobic tail. Okay, then we move on to the next category. The lipids in the food products could be separated into visible and invisible. Now, how many percentage are visible? 40%. Surprisingly, majority of the lipids in the food is invisible, 60%. So what are the examples of visible lipids? We call lard. That is from pig or swine or hog. In the Asian cuisine, when we cooking, they use lard a lot. We'll talk about that when later on. We also talk about taro, which means lipids, fatty acids coming from the beef, the cattle. And then we have manufactured visible lipids, like say margarine and shortenings. That's a manufactured. It's for food security, but really not a healthy food. Now, majority of that, or 60%, is invisible. You can imagine, sometimes you don't believe it. Fresh produce, even fruits, there is about 3 to 8% is lipids. You cannot imagine it. There are some lipids there, about averagely 5%, so range is 3 to 8%. Okay, so that's a next one. That's fine. So next one, we can also categorize the lipids into different resources. So we get to talk about is vegetable. Coming from vegetable, so we say vegetable oil. Now vegetable oil has a different category. It could come in from the seed. So for example, we have soybean oil. We just mentioned about soybean protein, so we have soybean oil. We have a sunflower oil. That comes from the seeds. It could come from the coating, the coat, which means the surface. So for example, you have olive oil. And it also could come from the canal, which means the center. So for example, if you get coconut oil, that's from the canal parts of a coconut trees or some fruits. So that's vegetable oil. But we are more interested about is another resource, is animal oil. Animal oil has 3 different categories. Number 1, we call it a depot fat. Now obviously we just mentioned, let's say lard, let's say taro. The animal oil could also come from dairy products. Then it will be belonging to, we call it a milk fat. Now milk fat, most of the time, therefrom is microbial fermentation, and in a cow products, in cows, then we call it ruminant nutrition. That's a different category. It used to be Dr. Jeannie Fadden and Marie Krauss did some research for that, written ruminant nutrition to see the interaction between the intestinal microorganism in cows. That will create the different fatty acids in the milk. But these days, we are talking about healthy foods. So we care about is the fish oil. What are the fish oil we want to talk about? Everybody knows is talking about EPA and DHA. So we're going to give you some of the hint. What are that? As a food chemistry class, you should know what is EPA. So what's the full name of the EPA? You can buy a bottle from like Whole Foods like CVS, Walgreens, or Puritan Pride, all those commercial stores. So what's the EPA stands for? That's icosa, penta, ionic acids. So what's that? That is C25 delta 5. That also means C20, 6, 5, 8, 11, 14, and 17. Now we're gonna get to that real quick when these things are means. Now what is DHA? You know, we mentioned the DHA last week. Dihydroalanine. That's really bad for the protein amino acids cross-linking. We don't like that, but here we really like it. So what is DHA? It's decosa, hexo, ionic acids. So what's that one then? That's more complicated. C22, 6 delta 4, that becomes C22, 6 delta 6, 4, 7, 10, 13, 16, and 19. Okay, so that's all the two very important. Fish oil. Okay, now let's talk about that. What is fatty acids? What is really fatty acids we talk about? Okay, fatty acids, we can write a whole universal equation or formula, which is CH3, yeah? Go here, OH. Now, what are these things here? That's CH2, that's CH2, that's CH2. Could be very long. So how are we gonna say it? They have two ends. This one CH3, meso N. That's everybody knows. It's important. We'll mention that. What is this guy? This should be right like that. COOH. Yes, we know. Carboxy N. And right in the middle, you see a very long, could be short, okay? Long CH2. What's that? Hydrocarbon. So that's what the fatty acids looks like. Now, we want to talk about something in general. The natural fatty acids, they are somehow, the chain is about 16 to 20 carbon, and it is saturated. But there are lots of others. So, the first category, based on the chain length, we could categorize the fatty acids as a short chain fatty acids, medium chain, and the long chain. Short chain fatty acids, most likely less than 10. Medium chain somehow from 10 to 14. And the long chain somehow it is more than 16 to can be very long. Okay, so that's some of the overview. Now, we mentioned here about saturated fatty acids. Based on the saturation, we could categorize the fatty acids as saturated and unsaturated. So saturated, there is no double bonds. Unsaturated, at least have one double bonds. Okay, so we talk about here. Then we want to go back, talk about something in detail. So some people are going to ask, you have a fish oil, EPA, DHA. These things you write here, and these things you write here. That looks like confusing. So we're going to get to that. Name of the fatty acids, what the system it is about. But before that, we want to spend some time, give you some examples about short chain fatty acids. This is 8. So give you some of the examples. So lots of us learning chemistry, they say, oh, that's CH3, CH2, goes COH, that's fatty acids. We know. But we may not be recognized. The easiest and the simplest fatty acids actually can be as simple as HCOOH. That's a fatty acids. You cannot believe it. That's formic acids. So where they come from? They come from the ant venom. This is for protection, for them to defend the enemies. There's some toxication there. It's also as antimicrobials, but we don't use that too much. Formic acids. We do like a sterilization of animal tissue. So lots of the time we use it in the museums to make those type of the templates. But this guy you know. So next one, CH3, COOH. What's that? Acetic acid. Acetic acid used for manufacturing, or is one component, around 5% become a vinegar. So we will talk about that at the end of the section of the fatty acids. We talk about the vinegars and manufacturing. Okay, let's get the chain a little bit long. That's 1 carbon, that's 2 carbon. How about this guy? CH3, CH2, COOH. What is this guy? Propionic acids. This coming from a very special bacteria, propionic bacterium. Now, where they comes from? Where is it? Why did it exist for propionic acids? If you buy a cheese, especially you buy a Swiss cheese, you see a Swiss cheese like that. That's propionic acids. And you see these holes, that's carbon dioxide. It's going through the fermentation of propionic bacteria. So that's 3 carbon. Okay, how about 4 carbon? CH3, CH2, CH2, so we go COOH. What is this guy? Butyric acids. What's a contribution where we can find? If you do a breakfast, have a bagel, and put a butter there, you really like it. The butter aroma. Surprisingly, that's coming from butyric acids. And there has been lots of the research has been done if we add a sodium, become a sodium biotonic acid, this guy will beneficial bond formation, which is improve the calcium absorption. So sodium biotonic acids, you can see lots of the research has been done by that. So on and on, we're not going to list everything. That's an example of the short chain fatty acids. But in our food products, in our food processing, we were more interested about these long chain fatty acids, especially a couple of the examples. So this gives you to move to a big topic of today. We want to talk about nomenclature of fatty acids. This means how we name fatty acids. So you see different name system. You see people say EPA, DHA. You see people say C29, 20,5, delta 5. You see even somebody write this. All kinds of things. Or sometimes people say that's oleic acids, that's stearic acids. So this makes it complicated and sometimes confusing. Luckily, we had a system. A well-recognized system is by International Association of Pure and Applied Chemists. So the acronym is International Union, not Association, Union. So IUPAC. They have a system to talk about this. Okay. The system encoding 3 different categories. The first category, I'll just write the second category, is common name. So for example, capric acid, that's a common name. Then the common name usually have numerical abbreviation. So capric acid, so what it looks like, what's a numerical abbreviation? That's C10, 0. What this means? This fatty acid is 10 carbon without any double bonds, so it's a saturated fatty acids. Okay, now, how about these? What they call it? That's they call systematic name. So in the food chemistry, you may spend lots of time talk about that, give you some of the puzzle. Capric acids, we call it, we can say it is, as the first one, we can say daconic. So let's say capric acids, the systematic name is daconic, and the numerical abbreviation is C10, 0. So DECANOIC, daconic. Originally, this is D-E-C-A-N-E, which is decane. Now, when they do the systematic name, this E replaced with O-I-C. That's very important to do that. That indication carboxy end. So that's the first introduction to it. Now let's give some of the examples. If we do C16-0, what's that? Palmitic acids. Okay, where they come from? When you see palmitic acids come from palm, it's a plant. Palm oil, we don't like that too much. People say it's not very healthy, and it's, if you don't know, lots of the palm tree at Florida, so there's a Palm Beach County at Florida. So palmitic acids, that's help you to remember. Now C16-0, what this means, that 16 carbon saturated fatty acids without any double bonds or no double bonds. What is the systematic name for that? Since it's 16, how we call it? Hexo, is that right? We call it a hexo. So, hexo, decaonic acid. Okay, that's palmitic acids. Okay, next one. C18-0. What's that one? Stearic acids. Stearic acids is a widely used saturated fatty acids from the beef. What that one means? 18 carbon saturated fatty acids without any double bonds. Now what is the systematic name? Since it's 18, how we call it? Octa, yes. So we become octa decaonic acid. Just want to make sure we, yeah, also the octa decaonic acid. So these are we listed here. Don't have any of the double bonds. It is saturated fatty acids. So we go a little bit complicated. Let's do this guy. C18-1. That means 18 carbon with 1 double bonds. Obviously, that's the first simplest unsaturated fatty acids. What's the name, common name of this one? Oleic acids. Oleic acid. Okay, how are we going to name here? That's become a little bit tricky. So how we say it? Octa decaonic acids. Once you have the double bonds, this becomes aonic. So octa decaonic acids. Yes, oleic acids. Okay, let's do a little bit complicated. How about let's put 2 double bonds? That's 18 carbon with 2 double bonds. What's that one? Linoleic acid. Okay, let's do that how we do it. That's octa deca diaonic acid. By the way, we need to know the position where that happens. So how we do it? We could also write that C18 to delta 9. And sometimes we write delta 12. We are going to that structure later on, okay? So delta system, which means you coming from here, that's delta system. Okay, let's do the last one, okay? Complicated one. C18, 3. That's 18 carbon with unsaturated fatty acids with 3 double bonds. What's the common name? Linolenic acid. Okay, how are you going to do the name here? Octa deca triionic acid. Now, the same thing here, what you do? C18, 3, delta 9, delta 12, and delta 15. So, that is examples. You can list on and on. We don't have to go that. That's nomenclature of fatty acids from the carboxygens. Then we go to a very common.
Do you need to place a delta in front of each bond? Where it says like 9, 12, and 15?
Yeah.
Okay.
You can add or you can skip it. You don't have to put delta everywhere. I just put it there.
Okay.
You can say delta 9, 12, 15, or you can do like this.
Okay.
That will make you more happy.
Okay, I just didn't know if it
Yeah,
was
good.
different for nutrition and then
I've seen
chemistry.
it both ways.
Okay,
Yes.
that's why I
So
was
it's just
wondering.
how-
That the
understanding
people
that that's
doesn't
more
really
about.
understand, but either way, if the chemist says they're gonna put delta there, but you can put like that way, it's okay. Yep. Okay, so that's numerical nomenclature of fatty acids from the carboxygens. Okay, you heard about these things. Omega-3. You heard about omega-6. So what this means? That's a question. Okay, what that means? It's relatively simple, we say. We wrote here, delta system coming from carboxygens. And I wrote the other end, I said it's a meso end. It is very important. We haven't talked about that. We can name, go to the right side, we also can name, go to the left side. That's omega system. So let's talk about that. You often the time see people write this. 18 commas 2 and 6. That looks like another very confusing one. What this means? That's 18 carbon unsaturated fatty acids with 2 double bonds. The first one is from the 6th position of meso ends. Okay, let's draw it. What it looks like. CH3. Go here, 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 here. 2, 3, 4, 5. Go here, go. Yeah. 1. Here. Go here, here, here. I may miss one. Let's see. Okay. Go here. So let's do the counting. Carbon number 1. Carbon number 2. Carbon number 3. 4, 5, 6. What we're missing here are double bonds. Okay, add it. So that becomes 7, 8. Every time it is around exactly 3 positions. Here, 10, 11, 12, 13, 14, 15. See, that's why I said I missed one. 15. Okay, so we go down. 16, 17. So that's 16, that's 17. This here is COOH. Now, what we call here, these position, that's CH2. This is called meso interruption. Okay? Now, by the way, all the position, it is CH2, you know that. So what's that one? Random gases. And what we call it? Omega 6, is that right? Omega 6. Okay. Now we have another one. What it means by 18? 3 and 3. The same thing, that can be a question by yourself if you're an instructor. That is 18 carbon unsaturated fatty acids with 3 double bonds. The first one is from the third position of the meso end. So let's do it then. So we get CH3 goes here. We should go, we make it uniform, we just go this way. Okay? So what's that? Carbon number 2, number 3, go this, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, that's 18. Okay, now, let's do a check. Okay, what is this one? Linolenic acids. This is linolenic acids. And we call it omega-3. This we named from the meso end. How about the carboxy end? Let's do a double check. If we go this way, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18. Do you see it? So you can check, you can check it. That's what we mean omega-3 and omega-6. And for yourself, if you want to generate a question, you can go ahead to see. EPA C2065 is from carboxy end. Go to the meso end. I believe one of them are omega-3, another one is omega-6, but you can do it. Okay? That's very interesting practice by yourself. And also, it's a good question. Okay, we get a couple of minutes. So there is the different system, which is from the meso end, we have omega system. Now, when you work in the industry, it does not mean everybody understands this chemistry. So lots of the time, they will just say 8,0, 18,1, or 18,C2. Lots of time they do like that. This we call shorthand description. Okay, so because that's for the people who do the food processing, they don't have a strong background of the chemistry. We have to do like that. Okay, the last one before we end, we want to mention hydrogenation. So we get a couple of minutes. We're going to talk about this. We mentioned linoleic acids. Linoleic acids, but there is a very simple one we haven't mentioned is oleic acids. Okay, so oleic acids we want to talk about the hydrogenation. So how are we going to do that? Oleic acids hydrogenation. Let's do from here. So 2, 3, 4, 5, 6, 7, 8, 9. We just do like this. 9, 10, 11, 12, 13, 14, 15, 16, 17, which 3. This is a double bonds. I'll just write line, for example. This is oleic acids. This is an unsaturated fatty acids. And we call it a cis configuration. During the history, people find that making a soap, they could generate some of the saturated fatty acids from the unsaturated fatty acids. And during the 1980s, when they are manufacturing a bread, they find the process, the bread will become extended shelf lifetime and prevent the rancidity. Because the process, we call it a hydrogenation. So what happened is this is the unsaturated fatty acids. You see the double bonds there. In a certain scenario, we could add the hydrogen there. So we could add hydrogen here. We could add hydrogen here. In what type of the scenario? We usually is doing proton. Okay, lots of the proton will be there. And also, we do pumping proton. So we pumping proton. At the same time, we need a catalyst, which is the nickel. We'll let that reaction happen more quickly. Also, of course, in the closed vessel, we need a certain temperature. Usually it's a higher temperature. Okay, now what happened? This reaction happens. Of course, the majority will become saturated fatty acids. But you know that the organic chemistry reaction is not 100% completed. It's usually either reversible. So there are lots of the byproducts will generate. And one of the byproducts will happen is 2, 4, 6, 8. What will happen? This line will go here. I just give you a demo. So this becomes a trans. Why? Because they think at this stage it is more energy stable from the chemistry standpoint. So you add hydrogen there to make it from unsaturated fatty acid become a saturated fatty. There's a lot of byproducts will generate, which is they do the rotated, they become trans fatty acids. This writing like there, if in a food chemistry, if in a chemistry class, they're gonna say wrong. What you should write? I tell you, it's very picky. They will say it's wrong. Two, 3, 4, 5, 6, 7, 8. Sorry, not here. This one should be right like that. This is exactly the trans fatty acids what it looks. Should be one more. That become a trans fatty acids. Trans fatty acids for oleic acids, they have another name. Eleic acids, electric acids. They have another name for that. It's not really oleic acids become trans. Okay, I just want to double check. Eleic acid. That's how that works. That's how that works. Okay? So, we finished here 15 minutes. Talk about the name and also talk about omega-3 and then introduce about the hydrogenation. We will mention something later on about the melting points and also the triglycerides. So next, so Thursday's plan is we will start 12:30 as original. We'll talk about, finish the section here. We go talk about triglycerides. Then around 1 o'clock, Ian will come to talk about the manufacturing of the chocolate. He may bring some of the chocolates. I have all the chocolates from him, is on my bench in my office. So because he did lots of research, and that's a good topic for the fatty acids. And you will see some of the manufacturing with the modes, and there's a migration, which means the fatty acids become white and migrated on the surface. If you put at room temperature for extended period of time, it's called blooming. That's not